Okay, welcome back. In this segment, I just want to give you one of the studies, an example of one of the stories I was involved in. In this case, we had a driller who was pulling oil out of the underground, basically near the shore in Louisiana, and the problem is that he was in the business of extracting oil. But as he was extracting oil, he was also extracting salt water, and he was extracting a certain amount of radiation in this mixture, if you will. So of course the oil went off to the refinery, and that's how he made his money. But now we've got this brine and we've got this radiation that we've got to figure out what to do with. So going down the list of options, my first thought is, hey, let's just shove it down the hole where it came from or nearby, so that it can't be polluting if it's back where it came from. And the answer from the people who'd been there longer than me was that no, we can't do that. That would be pollution. So we go through some of the other options. Obviously we're near the ocean, and you might be able to get away with putting salt water in there, but it's going to have a certain amount of petrochemical in there, and you certainly can't put in a radioactive brine into the ocean. That would be polluting. So we can't pollute down deep, we can't pollute in the ocean. And so then the question became, what do we do with it? And one of the things they actually did with some of it was they actually burned it, but still that doesn't take care of the radiation. It gets rid of the petrochemicals, but it doesn't take care of the radiation. You can't burn radiation away. So really the only option left seems like the stupidest thing you could do to me, but it was what was being required, and that was what was called land application. So basically the idea is you get this radioactive material that you can't dispose of anyway, and you put it right on the surface of the earth. And then the study that we were doing is, what is the risk factor associated with having this radioactive material on the surface of the earth? So in order to provide a risk assessment, we assumed that 10 years of supply of this radioactive material has been spread over the top surface. And then we assumed that cabbage was planted on this surface. And the reason we picked cabbage is because that is the one plant which soaks up radiation at the greatest rate. So, if you plant tomatoes or grapes or banana trees or whatever it is, that doesn't soak it up. So in order to increase the calculated risk to the maximum possible, and this is considered to be conservative, we decided to go with cabbage. In another conservative assumption, we decided that the farmer was eating his own cabbage. And he wasn't just eating a half a head of cabbage at dinner at night. He was eating all cabbage all day. And he didn't just eat one head of cabbage, he ate 2 heads of cabbage every day. Breakfast, lunch, dinner, he had cabbage from this field, which was pulling the radiation out of this surface land application. And then we ran numbers as to what are his risks. Another one of the conservative assumptions that we made is, how much of the radiation does he lose as he defecates? Obviously, you've got radiation coming in with the cabbage. How much is he losing as part of the standard digestive system? And the answer to that was 0. So every little bit of radiation that went in stayed in his body. And then the study is, with this radiation that is now in his body from eating all this cabbage that is from this radiated field, what are the risks? And so we ran those numbers and we came up with a number, and we sent that to EPA along with the report. Now, as you can tell, we've got a number of what's called conservative assumptions that are far from being realistic. Me personally, I don't like cabbage. I don't think I've ever eaten a total of 1 head of cabbage, but that's neither here nor there. We did those sorts of assumptions in order to be not called to task by somebody who said, hey, you're underestimating. So it's one way of covering your own hiney as the engineer to make sure that the regulators are not getting after you for underestimating risks. And then, of course, the regulators begin to expect those sorts of conservative assumptions. That is the picture that I would give to you for what the radiation engineering business looks like. Why is that important? Because those same sort of conservative assumptions were used in, not only in that particular cabbage study, but everything else that is done in the radiation engineering business, including assessments on radon. I thought that would be important to you. We'll come back and we're going to tell you why, or we're going to show you why homes act like chimneys to actually bring in the radon. With that, we'll be right back.